Hello, this lab we will conduct an experiment to determine the mass percent of sodium bicarbonate in Alka Seltzer. In addition to this presentation, before coming to lab, you must also read the introduction to the lab in the course pack and review the mass percent, stoichiometry, and limiting reactions in your textbook. The purpose of this lab is to determine the mass percent of sodium bicarbonate in Alka Seltzer tablet. Typically, we will use mass measurements to experimentally calculate the mass percent, graphically evaluate the limiting reactions, and practice making a diluted solution. Alka Seltzer is a base used to neutralize stomach acid, and the main component of the tablet is a sodium bicarbonate. In the presence of acid, for example hydrochloric acid, we will have the sodium bicarbonate react with chloric acid to form water, carbon dioxide gas, and sodium chloride. And carbon dioxide will be the product that we measure to indirectly determine the sodium bicarbonate already reacted based on this equation. And it is the molecular equation where we list all of the compounds involved in the chemical reactions. And we know that from the molecular equation we can also split out the compound and write it down as a total ionic equation or complete ionic equation. Sodium bicarbonate is ionic compound. When we dissolve in water, it will dissociate to form sodium ion, bicarbonate ion, and hydrochloric acid. When we dissolve in water, it will dissociate to form a hydrogen ion and a chloride ion. Water is a very weak electrolyte. It will stay the same as a molecular compound, similar to the carbon dioxide gas. For sodium chloride, because it is also an ionic compound, it will dissociate to form sodium cation and chloride ion. In the total ionic equation, the highlighted ions are called spectators ions, in which they do not actively participate in the reaction. They are present in both sides of the chemical equation. To make the equation more simple, we can remove the spectator ions and we will obtain the net ionic equation. Thus, the main components that involved in the chemical reaction is the hydrogen ion from acid reacts with the bicarbonate to form water and carbon dioxide. And we notice that this chemical reaction generates a gas as one of the products. And this is the observed fizzing when we do the chemical equation. In reality, when we do not have a hydrochloric acid and you just dissolve the tablet in water, in the tablet we have some citric acid as well. So when we dissolve the whole tablet in water, the citric acid can also provide the hydrogen ion to react with the bicarbonate to produce the carbon dioxide gas. From the chemical equation, for each mole of carbon dioxide gas produced, we have 1 mole of bicarbonate reacted. Therefore, the molar ratio of carbon dioxide and the bicarbonate is 1:1. Therefore, we can use this conversion factor to convert from the measured mole number of carbon dioxide to the mole number of bicarbonate. The last technique we cover is called dilution. Dilution is preparation of a less concentrated solution from a more concentrated solution. And the general formula is M1V1 equal to M2V2 or C1V1 equal to C2V2, where C is a concentration. In this case, we will focus on the molarity is a concentration. Therefore, we will write out the formula C1V1 equal to C2V2 in a more specific form, M1V1 equal to M2V2. This equation only works if you are using the same solution. It does not work if we have a chemical reaction. Again, the M1 is initial concentration, M2 is a final concentration, V1 is initial volume, and that is the volume, the portion of the stock solution we use to dilute, and V2 is the total final volume after dilution. We want to make 150 ml of 1M HCl, and you are given a bottle labeled 6M HCl. How do you prepare a less concentrated solution? First, we need to use an equation M1V1 equal to M2V2. M1 is 6M or 6 mole per liter, the concentrated solution. V1 is what we need to calculate for. M2 is the molarity after dilution, which is 1M, and V2 is total volume we want to make, which is 150 ml. We solve the equation and we obtain V1 equal to 25 ml. That means it is a portion of the concentrated solution we will use to dilute. So we will measure 25 ml of 6M solution and we mix that one with 125 ml of water in order to make overall of 150 ml of the diluted solution. There are several necessary calculations involved in the lab report. To calculate the mass of the carbon dioxide, you will do a subtraction. And to calculate the mass of the sodium bicarbonate, you will use the stoichiometry. And to calculate the mass percent of sodium carbonate, you will base on the mass of the sodium bicarbonate reacted divided by the mass of the tablet you used for the reaction. For example, what is the mass percent of sodium bicarbonate if you have an Alka Seltzer tablet of 3.234 gram, and after the reaction you measure the carbon dioxide gas and you obtain the mass of the gas produced is 4672 gram. To relate the carbon dioxide to and the sodium bicarbonate, we need to convert the everything to the mole number. So how do we get from CO2 to the mole of CO2? We will divide the mass of carbon dioxide to its molar mass, which gives us 0.0153 mole of CO2. Keep in mind that we should have a 3-citric for this calculation. After we get the mole number of CO2, we will use the molar ratio of the sodium bicarbonate over the mole number of carbon dioxide from the chemical equation, and we can convert from the mole of CO2 to the mole of sodium bicarbonate. After we get the mole number of the sodium bicarbonate, we multiply with the molar mass of the sodium bicarbonate to obtain the mass of the sodium bicarbonate present in the tablet. After that, we will divide the mass of the sodium bicarbonate to the total mass of the tablet to obtain the mass percent. Regarding safety for this lab, lab goggles and lab coat must be on, and the 6M HCl solution is pretty concentrated and it's a strong acid. If you spill the hydrochloric acid, make sure that we should clean up immediately with a loss of water and try to avoid a contact with skin. And if you get it spill on your skin, make sure you flush the skin area with loss of water and have someone notify the instructor.